Good afternoon, my students. How are you? I hope that you'll be okay and your family also okay. I hope you stay in your home. Today we need to talk about our topics that we need to complete also our topics that we finished before closing the schools. So we need to complete our topics with you, Mr. Chadi Eldib from Tabarak Private Schools.
Assalamu alaikum warahmatullahi wabarakatuh. How are you, my students? I hope you'll be fine. Grade 12. How's everything? How's your study? How your topics? Everything will be okay, inshallah. Today we need to continue the superposition, last point or last part in this chapter. Superposition. Today we need to continue Young double slits. Young's double slits. It's a very important experiment and we have to understand it very well. Young's double slit experiment. We have a famous force scientist, his name is Thomas Young. Thomas Young demonstrated how light waves could produce an interference pattern. Look at this. We have here a monochromatic light. Monochromatic light, we said it before that it's one color. I told you before it's one color. One color means red only, blue only. This is monochromatic light. Because interference, it's more clear in monochromatic light. But for white light, it's not monochromatic because it's a mixture of colors. So it's very difficult to show interference in this light. So we have to get monochromatic light. Monochromatic light means one color. Okay, in this experiment, Young preferred to use red color. Why red? Because red has a long wavelength, so the pattern can be observed easily. Now here we have interference, constructive and destructive, crest with crest, trough with trough, crest with trough. So what will happen after interfering for these positions, crest with crest, trough with trough, and crest with trough? We have something on this screen, bright dark, bright dark, bright dark. What's this bright dark? This pattern it's known as fringes. Fringes, dark fringes, bright fringes. So bright fringes means crest with crest or trough with trough. So we have constructive at this part. But dark pattern or dark fringe means that we have here destructive interference. Means crest with trough. So Young's double slit experiment comes for what? Comes to produce an interference in light waves. Now, in Young double slits, the second part for the aim of this experiment to find the value of wavelength. We can find the value of wavelength. So how can we use it? We have some distances and some expressions in this experiment very important. Number one, x. What's x? X is the distance between the screen, distance that produced on the screen. The distance x, on the screen is the distance between successive bright fringes, and it called fringe width. So again, the distance x on the screen between any two successive bright fringes, especially successive, I said successive, means bright fringe number one and the second one, bright fringe. So this distance is known as fringe width. Also, x equals lambda d over a. Okay, what's d? D is the distance from the double slit to the screen, and a is the distance between the centers of the slits. But put it in your mind, the wavelength of the light is so small to produce observable fringes, d. So d needs to be large and a as small as possible. It's very important for you. And this question in final exam, it's very easy. Why? Because you know x. What's x? X for you is the distance between any two successive bright fringes, or fringe width. Very easy. He can draw or he can put the diagram for the experiment, and he labeled the points and the distance also x, d, and so on, and ask you, please find the value of lambda. So it's a very easy part to find it. Look at this example. He said calculate the observed fringe width, means x, for a Young's double slit experiment using light of wavelength 600 nanometer and slits 0.50 millimeter apart. The distance from the slits to the screen is 0.8. So using the formula x equal lambda d over a, lambda in nano, so we have to convert it, multiply or times 10 power negative 9. Also, lambda, we have it. D, we have it, the distance between the slits and the screen. So it's 0.8 and it's in meter, no need to convert. Divided by A. A is what? A, we said it before, the fringe width. By finding all of this mathematically, we have to find the value of x. X equal 9.6 times 10 power negative 4 meter. So this is very important for you. Sometimes we can write it in millimeter. How can we do it? From millimeter to meter times 10 power negative 3, from millimeter to meter. But if we need to do the reverse, times 10 power 3. So you can find it very easy. Now let's talk about the second part in this topic today, stationary wave. Stationary wave, this wave around us every day. Around us. What's this stationary wave? A stationary wave is the result of interference between two waves of equal frequency, amplitude, but traveling along the same line with the same speed, but take care, in opposite direction. So you have to put it in your mind, what are the conditions of interference or for stationary wave? Equal frequency, amplitude, traveling along the same line, 3 points now, but in opposite direction. This stationary wave, it consists of two parts. One is known as node and the second one is antinode. Node, the amplitude or the maximum displacement at node equals 0. No amplitude, 0. But in antinode, the displacement is maximum. So in front of you now we have one mode or one section. Okay, so this fundamental mode of vibration of a stretched string. I said one section, one section. One section. It's very important because we need it in substitution in formula of stationary wave. So L in this case equals lambda over 2. But if we have two sections like this is the second mode. Second mode of this wave. So L equals lambda. But look at the third one. We have to find three what? 3 sections. Okay, this 3 sections or 3 loops. L equals 3 lambda over 2. This is third mode of vibration. You have to save it in your mind. So finally, what's the formula here? The formula now, how can we find the frequency? F equal NC over 2L. You have to put in your mind that C here not constant. C is the speed of the wave. The speed of the wave. And L is the length. And this is frequency of nth mode. Or sometimes we can say the nth harmonic. Or n minus 1 for overtone. Because if he said third harmonic, so it's okay, third harmonic, it's very easy. But if he said third harmonic, it's very difficult. 3 minus 1 equals 2 overtone. So if I ask you, third harmonic represents what? Second overtone. Thank you very much. I hope you will be fine. I hope you understand this, inshallah.
Thank you for your listening, and also thank you for your caring for what we explained, and thanks also for the chairman of our school, Mr. Yunus Rahbi, because he did everything related to make this process very cooperative, related to new technology in education, and how to process this technology to reach all information to the students. So thank you, and don't forget that the homework also uploaded in model in the website of our school.